This will be for the Khan Academy exercise, right triangle trigonometry word problems. All right, so you should be familiar with the trigonometric functions by now. Okay, the three trigonometric functions are sine, cosine, and tangent. They are abbreviated SIN, COS, and TAN. Okay, this symbol right here is a Greek letter theta. That just represents the angle. And the way to remember the formulas is to remember the phrase so, ka, toa. Okay, the S is for sine, the C is for cosine, the T is for tangent. And as far as the lowercase letters, O is opposite, A is adjacent, and H is hypotenuse. So remember, sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent is opposite over adjacent. Okay, you should be familiar with that prior to this exercise. All right, some more notes before we begin. So you want to remember the horizon is basically a flat horizontal line that moves left to right. Horizon, horizontal, that's where the word comes from. Okay, and if you use that as one side of your angle and you make an angle going up, okay, that right there, that angle right there going up is going to be your angle of elevation. Okay, and once again, if you start at the horizon and you make an angle going down, that angle right there is going to be your angle of depression. Okay, so nothing fancy here. These are just definitions for angle of elevation and depression. Remember, they need to use the horizon, the flat line going left, right, as one of the sides of the angle. All right, so you can read the write-ups, but most of the info is on the diagram. It says Bob is building a cabin. The cabin is 30 meters wide. He obtained a bunch of 17-meter wooden beams for the roof. Naturally, he wants to place the roof beams at an angle that each pair would meet exactly in the middle. What is the angle of elevation in degrees of the roof beams? Round to the nearest tenth. All right, so this right here is our diagram. And we can assume that he's going to make this even or symmetrical on both sides. So if this one is 17, this one here is 17 as well. Now notice there is a right angle here. So if you draw in the height of an isosceles triangle, remember the isosceles triangle has two congruent sides. If you draw in a height perpendicular to the base, it is going to bisect the base or cut it in half. All right, so in other words, if you have a triangle and you have two sides congruent and you draw in a height and make a right angle with the base, it's going to cut the base in half. So half is going to be on the left and half is going to be on the right. All right, this works for an isosceles triangle when the sides are congruent. Anyhow, if this base here is 30, this base here is also going to be 30. All right. And since we have an isosceles triangle, each of these is going to be half of 30 or just 15. All right, I'll do it in a different color here. This is 15 and 15. Maybe you can't see that. Let me see. 15 and 15. All right, so let's see. So we don't need to worry about this triangle here. We're just trying to find this angle, the angle of elevation. Remember, you start at the horizon, and if you travel up, that's your angle of elevation. So we're just dealing with this triangle. If we could label the sides in relation, relative to this angle. Recall, if you go across from the angle, that side length is your opposite. All right. If you go across from the right angle, that side length is your hypotenuse. And finally, the remaining side is going to be your adjacent. All right, so like I said, we're ignoring this triangle. We're just using this triangle on the right. Here is the angle. We have the hypotenuse. we have the adjacent. So let's see if we recall so, ka, toa. Which one uses adjacent and hypotenuse? Well, that's this right here. All right, so clearly we are using the cosine function. All right, the C stands for cosine. This angle here, we can call it theta, Greek letter theta. And that's going to equal, according to the formula, adjacent divided by hypotenuse. All right, I'm going to make a little room here on the bottom. Use whiteout. All right, and we're going to leave some space on both sides. So we have cosine of theta. I'm just rewriting now. We don't know theta. And leave some space. Adjacent is 15. And hypotenuse is 17. All right, so cosine of theta equals 15 over 17. Now, solving for theta, you cannot just divide both sides by cosine. This whole thing is one number here. So instead of cosine, the way to cancel that is to do inverse cosine. Okay, it looks like cosine to the power of -1, but that's not what it means. It's actually inverse cosine. So we're doing inverse cosine of this. And on the other side of the equal sign, you want to do inverse cosine. Okay, and that's of 15 over 17. Inverse cosine of the cosine cancels, and we are just left with the angle theta. That's what we're solving for. I'm going to do inverse cosine of 15 over 17 on the calculator. Make sure you are set to degrees, and let's round off to 1 decimal place. All right, let's go to the calculator. All right, make sure you're set to degrees. And I'm going to do INV, inverse cosine of 15 divided by 17, close parentheses. All right, it says arc cosine, but that's the same thing. Hit equals, and we're rounding to 1 decimal place. So 28.0, you look at the second decimal. If it's 5 or more, you round up. 28.0 is going to become 28.1, and that is in degrees. All right, make sure your calculator is set to degrees. If you need help, see me. All right, 28.1. All right, like I said, some of these you really don't need to write up. Galileo wanted to release a wooden ball and an iron ball from a height of 100 meters to measure the duration of the fall. He found a plane with an incline of 12 degrees that he could climb until he could get to an altitude of 100 meters. How far should he walk up the inclined plane? Round to the nearest hundredth. Okay, so we're trying to figure out how far he walks up the plane. So I guess we can assume. So I'm assuming he starts here, and we're measuring this distance right here to get to a height of 100 meters. All right, so we have 12 degrees here, and this height, doing a different color here, this height would have to make a right angle with the ground. Okay, so that is your right triangle. It's basically solving for a side. Let's label the sides anyhow. This is the only angle given, 12 degrees. So you go across from that, and that side is considered your opposite. All right, you go across from the right angle, and that side is considered your hypotenuse. We don't know what it is, the length, so we'll just call it X. And the remaining side is your adjacent. Okay, so if you recall so, ka, toa, we're dealing with opposite and hypotenuse only. All right, so if you recall so, ka, toa, which one uses opposite and hypotenuse? Well, opposite and hypotenuse are O and the H, so clearly it is the sine function that we're going to use. All right, so let's write the formula first based on SOH. That's going to be sine of an angle theta, and that equals opposite divided by hypotenuse. That's what the O and the H stands for. All right, let's see. The angle theta is the angle is 12. So we have sine of 12 degrees. All right, you can use parentheses if it helps. And that equals opposite, which is 100, divided by hypotenuse, which is x. Okay, lots of ways to do this. You can cross multiply if you like. But since x is in the denominator, what I like to do is just take the reciprocal of both sides, okay? Let's assume this is over 1, all right? That doesn't change anything. And what I'm going to do is, since we have a fraction on both sides, I just take the reciprocal of both sides. So sine of 12 over 1 is going to become 1 divided by sine of 12. And 100 over x is going to be x over 100. Okay, now we're in business because x is in the numerator. Again, you don't have to do it this way. If you like to cross multiply, you can certainly do it that way. Solving for x, the opposite of divided by 100 is, of course, times 100. I'm going to do that to both sides. Times 100. All right. On the right, it cancels. On the left, the numerator, 100 times 1 is just 100 divided by sine of 12. So that's all you have to do, 100 divided by sine of 12. And round to the nearest hundredth. All right, make sure you're in degrees. 100 divided by sine of 12. Close parentheses, hit equals. And let's see here. They said nearest hundredth. So that's 2 decimal places. Look at the third decimal. If it's less than 5, you round it down. So 480.97. Does the answer make sense? Well, in order to climb a height of 100, you're going to have to travel more than 100 meters here. Okay, so I'm pretty sure that makes sense. 480.97. All right, like I said, most of these you don't need to read, okay? So they're asking, what is the angle of elevation in degrees of Bugs Bunny's climb? Round to the nearest 10th. All right, so angle of elevation. We said that is the angle being made with the horizon. Okay, this right here, the flat would be the horizon. This angle right here would be the angle of elevation. Okay, so this is the one we're trying to solve for. This is the angle theta. All right, since this is a height, we can assume that this goes straight down and makes a right angle with the ground. All right, step 1, label sides. As always, if this is your angle and you go across from the angle, that side is going to be your opposite. Okay, if you go across from the right angle, that side is going to be your hypotenuse. You can label this adjacent, but really you don't need it. And this looks just very similar to the last problem. We want to find the trig function that uses opposite and hypotenuse, O and the H. So clearly it is the sine function. All right, sine of the angle theta equals opposite divided by hypotenuse. All right, so continuing, and we're going to have to do inverse, so I'm going to leave some space. Sine of the angle theta, that's going to equal opposite, which is 42, divided by hypotenuse, which is 100. Okay, this is our equation. We need to solve for theta. You can't just divide by sign. This is all one number. So the way to get sign to cancel is to take the inverse sign. Okay, it looks like sine to the -1, but that's really inverse sine. And you want to do that to both sides. You have to do inverse sine on this side as well. Okay, maybe you can't see that. You have to do inverse sine of 42 over 100. On the left, sine and inverse sine cancel. You're left with the angle theta. Inverse sine of 42 over 100. Let's go to the calculator. Make sure you're in degrees. It's basically inverse sine of 0.42. All right, inverse sine of 0.42. Same thing as 42 over 100. It equals, I think they said 2 decimals. So we'll try 24.83. Check the third decimal. If it's less than 5, you round it down, 24.83. All right, they said nearest tenth, 24.8.